Hey everybody, welcome, and thank you so much for joining us. I'm Tony,
I'm Bhargav.
and we're so excited to be here today to talk to you a little bit about AI and robotics and how it's changing the industry. But before we get started, I have to shout out a huge thank you to the RiOT team and all of you for being here. The work that RiOT's done to build up this community here locally is incredible, and it's so exciting to see on days like today. So before we dive too deep into the technical details, we wanted to take a step back and look at what actually is Industry 4.0. And I have to tell you, we've been to a lot of trade shows recently and asked this question. If you ask 30 different people, you're going to get 30 different answers. It's one of those terms that gets thrown around all the time, and there's not a ton of clarity around what it actually means. But I have come away with one firm thing that we can land on, and that's that it's totally different from Industry 3.0. So no confusions there. But before we, kind of get too deep into the technical stuff, I also want to make sure we have a kind of a shared understanding of what is automation, because it's another one of those terms that gets thrown around a lot, and there's not usually a ton of clarity around it. This is my personal favorite definition, and it comes from Michael D. Hyatt. He's the author of a book called Free to Focus. And it's really this idea that you solve a problem once and then put that solution on autopilot. And so oftentimes we think about automation in the context of technology, and that's absolutely appropriate, but you can automate anything. You can automate an email signature by kind of having it in your inbox, right, and ready to go. You don't necessarily have to use a chatbot to paste it into the body of the email, but just by doing the thinking ahead of time and putting it on autopilot in the moment, that's absolutely still automation. So when we think about the future of automation, I like to go back and understand a little bit about the history of automation, especially because there's a really interesting story that unfolded right here in North Carolina with a brand that's near and dear to my heart. So if we go back to the year 1937, an iconic establishment opened its doors for the first time. That's Krispy Kreme. But it didn't look like the Krispy Kreme that you might know and love today. They were more of a manufacturing facility that sold donuts directly to grocery stores to then be sold to consumers. They did not sell straight to the consumer. And so they didn't have an actual storefront. They had a manufacturing facility situated in an industrial sector in Winston-Salem. Well, what happens in those types of environments is you had a lot of other folks coming into work in other factories that would come in and on their way into work, smell the donuts cooking and be kind of clambering to get some, right? But they weren't available for sale to the general public. One of the business partners spotted this as an opportunity. And before we get a little bit further into that story, I want to back up and mention one thing, which is it's super important in automation and using AI tools to make sure that you're choosing the right tool for the job. Well, the right tool for this opportunity was a hammer, and the job was knocking a hole in the side of their facility that created the world's first hot now sign. And so it's not always about the most technologically advanced solution that delivers the result. It's not always about something that's flashy. It's not always about something that is super advanced, but it is just about understanding what the opportunity is and using the right tool to take advantage of that. Now, this isn't where Krispy Kreme's automation journey ended. They were pioneers in early fixed automation, using conveyors to move donuts through their facility, using advanced mixing methods to ensure the exact amount of yeast to get that fluffy center, using kind of a Willy Wonka style frosting fountain, if you've ever been to one of their shops, that gets the exact amount of glaze on every single donut, so that every time you bite into a Krispy Kreme donut, you know exactly what you're getting. And that's one of the key things that drives a lot of people to pursue automation, is this idea of consistency and getting the exact same thing every time that you can rely on. And obviously this created some pretty incredible business outcomes for Krispy Kreme. Billions of donuts sold annually, 1.8. That's an eye-smacking number of donuts. Many of them to me personally, I have to say. $450 million in revenue in 2023 and almost a $2 billion market cap. So automation clearly has an impact here, right? And it's super important, especially as we think about how we apply automation in different contexts. It's a powerful tool, but it's also surrounded by a lot of hype. And so one of the things that we like to talk about is what is a technology trend versus kind of a fad. What's a fad versus a trend?
So a fad, I'd say, is something that is only out in the market for a little bit of time, and then it goes away. No one really thinks about it afterwards. So my favorite example is the fidget spinner. When's the last time y'all have seen a fidget spinner? But this was all the craze a couple years ago. I definitely had a couple.
I hear the noise in my dreams.
Whereas a trend is something that actually creates a fundamental shift in the industry and is kind of like a paradigm shift and sets the tone for the next couple of decades in technology. So the smartphone is a perfect example of that.
And I think one of the key distinctions is it changes the way that we interact with the technology. It changes the way that we do something in our everyday lives, right? And so you all are, very exposed to the world of technology. So I'd love to hear what are some examples of trends or fads that you all might be exposed to?
Definitely see a trend toward personalization and privacy respecting with mobile tech.
Absolutely. That's not going away, right? That is changing the way that we interact with a lot of these tools in a very real way. Does anybody have a good example of a fad? I'll say that a lot of people make an argument that crypto is a fad, but it's hard to know sometimes at the front end of these technologies whether they will become a trend long term or they will pass away like a passing fancy and be a fad. So this conversation is also playing out in the world of robotics right now, where we have kind of this growing conversation around how do we select the right tool for the job and what really is the right tool for the job. And a lot of that's playing out in this kind of divide between humanoid robotics and task-oriented robots.
So what is a humanoid robot? Well, it's kind of in the name. And my favorite example is think Rosie from the Jetsons. So it's a robot that kind of looks like a person. Doesn't have to look exactly like a human, but basically has a head, torso, 2 arms, and 2 legs. And because of this form factor, they're able to have different functionalities. So they can do many things like vacuum your house, wipe surfaces, do your dishes. I've also seen a robot that takes care of your kids. It could do many things. Whereas task-oriented robots are really good for one specific function. So think of a Roomba. A Roomba is perfect for vacuuming your house, but it probably won't do your dishes. It probably won't make you food. I probably don't want it taking care of my kids.
So
Yes.
when you think about designing a robotic solution that actually helps you with housework, you might think that you want Rosie from the Jetsons, kind of a one-size-fits-all machine that does everything. But the reality is you might want several smaller task-oriented machines to be more effective at those particular jobs. You'll notice that we see a lot of Roombas out in the world today. We don't see a lot of Rosie from the Jetsons. And so this is, yeah, exactly. Well, that's the key question, right? Is are humanoid robots more of a trend or more of a fad? I think we would make an argument that they're a little bit of a fad, maybe with the possibility to become a trend. But where we're seeing a lot of adoption and the real business value drivers right now is in the world of task-oriented robots. So now you might also say, which one of these is actually a reflexive robot? And the reality is that both of them can be, and it just depends on how you apply the technology to it, right? Again, it's about picking the right tool for the job. But what actually is a reflexive robot?
So a reflexive robot is one that kind of, if you just think about it, has reflexes like a human. So it can respond in real time to changes. It's constantly learning. So we define it in 3 ways: responsive, instructable, and adaptable.
And it's basically this idea that it's actually, first of all, aware of its surroundings, right? It's able to gather information about the world that it's in. It's able to use that information to make real-time decisions to adapt its behavior. And it's able to interact with humans in a way that's effortless and seamless. So it's as easy to give instructions to this type of robot as it is to give instructions to anybody that you work with. Now, obviously, this is a complicated technical challenge, and this is only enabled by a few key trends that have been growing over the recent years.
So first, there's 3 key systems that make a robot have reflexive capabilities. First is sensory perception. So it's like giving these robots the sense of sight, the sense of sound, and the sense of touch. And we'll get into more detail on that in a bit. And the next one is low-code interface. So what we mean by low-code interface is that we basically aren't programming the robot explicitly through lines of code on what to do. It's kind of it's more simpler, telling the robot a set of instructions. That could be verbal, that could be just typing it out. But it's one level above coding exact movements for a robot. And the third piece to that is advanced training. So this typically refers to using AI or machine learning techniques where the robot learns the task and continuously improves on itself based on how it performs that task.
If you map these, oh, sorry, go ahead.
So you're calling this reflexive robotics. What is it in contrast to? Isn't this what robots do now?
We normally think about it in contrast to like fixed robotic systems. So the easiest way to think about it is if you ever heard the term fragile, right? It's something that when you expose it to stress, it gets weaker over time. Reflexive robots are, because they're able to learn in real time, able to be what we call anti-fragile, which is when you expose them to stress in new environments, they learn, grow, and get better, in contrast to fixed automation systems like a conveyor belt, which if you use it wrong is only going to get worse, right?
So if you think about like in a manufacturing line, if there's parts coming down the line and the robot is set to like maybe like solder something at these exact XYZ coordinates, what if there's like some anomaly and the circuit board or something is moved like a millimeter to the right? Now when it goes to solder, that whole circuit board is completely wrong and unusable. So it hasn't adapted to the change in environment.
But to directly answer your question, the trend is very much that all robots are becoming more reflexive. And so it's really not, kind of a divide between two current branches of technology, but it's kind of the past versus the future of robotics, if that makes sense. If you want to map these characteristics to a human, an easy way to think about it is, kind of the sensory perception piece are like our senses. It's like our eyes, ears, nose, mouth, and hands. The low-code interfaces are kind of like our brain. They define the logic that dictates how the robot should behave in different circumstances. Now, we don't want to get too granular with it. We still want them to make decisions in real time, but we want those decisions to have some guardrails that make sure that we're all rowing in the same direction and still accomplishing the task. And then the advanced training and machine learning component here is really kind of like sending the bot off to school or to university to learn new skills. So if we get a little bit deeper into the sensory perception piece here, a lot of that is, like we said, kind of the eyes, ears, and hands of the robot.
So the eyes are like the computer vision aspect of the robot. So typically we use RGB cameras for just like normal color detection like our eyes work. But then we combine that with depth sensors. So it could be LiDAR, it could be time of flight, any sort of depth sensing technology to give it that 3D spatial awareness rather than just the 2D.
On the audio perception front, we're normally talking about microphones, and those can be positioned anywhere in the facility. And tactile sensing is basically just pressure sensors and force torque sensors and things like that. The key here is that in addition to each of these kind of input devices, you need an AI system that's able to combine these inputs and actually create a real understanding of what's happening in the world, basically. So it knows what it's looking at. It's looking, not just seeing.
So it's a combination of large language model and other AI models then?
Mm-hmm.
Definitely,
sure,
yeah.
So computer vision models, large language models for auditory, all in combination with tactile sensing can help it give like awareness.
What would be the model? I'm trying to think of the AI as the question for the tactile.
So they don't always need to have AI in each system. So for tactile sensing, it could be as simple as just force torque sensors in like a gripper. You can like read its pressure, and based on that, we can determine, all right, it's pressing too hard.
Yeah, and there's a branch of research called adaptive inference AI, which basically allows the robot to combine that tactile sensing ability with something like vision to see how a task is being performed in the real world. For example, one really cool demo that we've seen a lot is basically a square nut that the robot needs to turn, right? And you can train it on a square nut, then swap the nut with a circular nut and view if the nut is actually rotating. That determines how much actual force needs to be applied there. And so it's an input mechanism, but it needs to be connected with kind of the rest of the brains there. On its own, tactile sensing, you might, for example, measure how hard you can squeeze an egg, then measure the force that results when the egg breaks and know that that's your threshold. And so that's really the AI component, is kind of just learning through experience. Yeah.
Well, smell.
Sorry?
Smell.
Smell is definitely an important one, yeah, and that's a question that we get all the time. It's interesting is, we look to automate some things in kind of chemical production and material handling in that space. Olfactory senses are a super important error detection mechanism. And so there are a lot of sensors out there that can do that as well. In terms of kind of detecting particles in the air, it's not always smell in the way that we traditionally think about it, but it's more often kind of detecting parts per million of a certain molecule in the air and using that data to make an inference about what it might smell like. Now, all of this sounds good in a lab environment, but I'm sure you'd like to see what it looks like in real life. And so one of the things that we do at Blue Sky Robotics is create computer vision systems that enable the robots to work more autonomously. And you're going to see that right here.
So what we have here is a 6-axis robot with a camera attached to the end effector. That camera is looking down on the objects right here, and you can see that it differentiates between bottles and boxes. It puts a bounding box over each one and then gives you a confidence score of how confident it is that object. So this utilizes the RGB sensor that I talked about in order to see the world in front of it. And now we utilize the depth sensor on the camera to give us this point cloud image. You can see that the bounding boxes have turned into bounding cubes, these yellow cubes, and now we have in depth. Now we know the X, Y, and Z component of
Each object of interest, and now we can tell the robot to go pick and place objects. With that information, we can have robots painting 3D objects. We can also use it for sandblasting. Honestly, we could use it for anything.
And it's a good example of how you can see where we combine different sensory inputs to create a shared understanding of the world around us. So for example, we use the RGB sensor to do the identification piece that allows us to sort objects by type or any visual characteristic there. And then we use the laser view or the point cloud view to determine where those objects actually are in 3D space so that we can pick them up and interact with them.
And the point cloud view is pretty cool because not only do we know the XYZ, but we know the shape of the object too. So if it's like a rounded, if it's like an egg, like Tony mentioned earlier, it's a rounded object, and we can't just pick it straight up every time. With the shape, we can determine the best picking strategy without actually breaking the egg.
Now, obviously, all of this information is useless if you don't have the logic that determines how you actually need to interact with that. And so these low-code automation interfaces are basically ways that we can tell the robot how to behave in different environments. What is your actual work area that we want you to stay inside of? What do we want you to do when you detect this part? If we say sort these bottles by color, where do you put the red ones and where do you put the blue ones? And so it's a component of kind of teaching the robot how to behave in different environments. And like I said, we want it to be able to make decisions autonomously and move through the world with autonomy and be able to make those decisions in real time. But we want them to happen inside of certain guardrails that still protect the people around us and still kind of take safety considerations into concern, as well as have an understanding of what the task actually is. So this is an interface that we've built that basically allows you to, using simple words and simple mathematics, be able to define a workspace for the robot, define logic that tells what should happen when you recognize different parts and what you should do with those parts. It also provides us a centralized interface for you to control multiple AI components. So you might, for example, have a computer vision source. You might have simultaneously an audio source that's waiting for commands. Each of those could trigger motions inside of this development space.